Alright, so today we're talking about section 7.5, which is linear inequalities. So we have worked with inequalities before, back in chapter 4, and we solved inequalities and we added numbers to both sides of our inequality, and we divided by numbers. And the one thing I want to remind you of, and something that you're going to see later in this video, is that when you multiply or divide by a negative number, you have to flip that inequality symbol, okay? So we're going to take inequality similar to what we've worked with before, but now we're applying it more to these style graphs, and we're roping in the knowledge that we've just learned about systems, and we're going to kind of put the two together to graph what's called linear inequalities, okay? So first vocab word, a linear inequality describes a region of the coordinate plane that has a boundary line. Okay, so a linear inequality, and again, we're going to go through notes, and you'll see a couple of examples of what a linear inequality is. But the key thing is that it describes a region. So a region is a section of the graph. And coordinate plane just means of a graph like this that we've been using to graph. Okay, and it has a boundary line, meaning it has a line that determines where that region stops. So then the solution of an inequality, or the solutions of an inequality, are the points that make the inequality true. In other words, and I want you to add this here, it's talking about the shaded region. And again, you'll kind of see what I mean here in a second when we go through and we start graphing. But it's going to be the shaded region is your solution. So it's not going to be an intersection point like we talked about with section 7.1 with graphing. We were looking for that intersection point and where our two lines intersected. And we're not looking for that in this section. We are just looking for the area or the section of the graph that is being shaded. And we're going to talk about what that means to shade, how to shade, and that kind of stuff in this notes lesson. So first I want to go through, and I want to go through a couple examples with you, talking about shading our coordinate plane and what does that look like. So this column over here is going to be positive slope. And this column over here is going to be negative slope. Okay, so these graphs are only going to have positive slopes, and these graphs are only going to have negative slopes. I'm making up these lines because right now we don't have any numbers involved, but I want you to pay attention to the way I'm graphing, and I want you to pay attention to the types of lines that we're using and that kind of stuff. So this symbol is our greater than symbol. And if you remember back to our inequalities unit, we had two different types of circles. We had one circle that was open and one circle that was closed. So our open circle meant greater than or less than, right? And our closed circle, so our filled in circle, meant greater than or equal to or less than or equal to. So that closed in circle meant equal to, right? We have two types of lines in this section. So we're going to have a solid line. So a solid line is going to be greater than or equal to or less than or equal to, and it means equal to. Okay, but we will also have a dashed line, and a dashed line means greater than or less than, and more importantly, it means not equal to, okay? So very similar to our graphs before when we would have it on a number line, right? We had an open circle and we went this way, or we would have a closed circle, right? And go either direction, let's say this way. The closed circle here meant that we were including whatever number this is sitting on the number line, versus the open circle means that you're not including that number, but you're getting very, 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 very close to it. The idea is the same now with our solid line and our dashed line. So our solid line means it equals that line. You can pick a point on that line. But the dashed line, meaning not equal to, means you can't pick a point on that line. You can get very, very close to it, but you can't actually pick a point on that line. And let's see what that looks like. So we have a greater than symbol, which means it's going to be a dashed line. And I have a positive slope, so I'm just going to make a positive sloped line like that. And you see how it's dashed? It needs to be obvious. So when you go through and you graph, it needs to be obvious to not only your eyes, but to my eyes and anybody else that might be looking at your work. So it needs to be more obvious that it is a dashed line. So you need to make sure it's nice, dark, and obvious that it's a dashed line, not a solid line. So then after we have our line, so it's going to be a dashed line, okay? And it's greater than. So we need to ask ourselves, what side of the line is greater than our line? Is that going to be up top here? Or is that going to be down below? Greater than, you're thinking numbers that are larger, that are greater, that are higher. So you want to shade this section here above your line. Okay, again, with your shading, be very careful. You don't want to make your shading so dark that you can't see behind your shading, but you also don't want to make it so light that you can't see the shading. So it's going to take some practice and it's going to take some getting used to, but please be neat and careful when you are shading and drawing your line. So you should still be able to see what type of line you have even after you've shaded. Okay, so let's do the same thing, but now we have a negative slope. So negative slope, it's still greater than, so I still have my dashed line, right? Greater than my line, so it's going to be up top here. I'll shade it in. And that's it, okay? So this is greater than or equal to. So what kind of a line am I going to have? Am I going to have solid or dash according to our information here over the side? It's going to be solid. So again, my positive slope, because that's this column. And again, guys, these are just examples. These are not, true problems that you're going to see throughout this section. These are just some basic starters, okay? So positive slope, it's greater than or equal to. So because it's equal to, it's a solid line. We're looking for the section of the graph that is greater than this line, and that's going to be the section above again. Okay, but again, you should still be able to see what section is shaded and whether you have a solid or dashed line. Negative slope. So same thing, solid line. But negative slope. I still want greater than or equal to, so that's going to be above. Okay, so then the next one. Positive slope line, it's less than. So because it's less than, we're going to have a dashed line. Again, positive slope, so I'm going to go up in this direction. Draw my arrows. Okay, it's a dashed line because it's not equal to. So now less than. Is less than going to be up above the line or down below the line? It's going to be down below the line this time. So again, shade down below of your line. Okay, same thing, negative slope, so I'm going to draw my dashed line in here because it's still less than. Negative slope, I went down below my line again because it's less than. Shade in the area, and I can still see that I have a dashed line. So last two, less than or equal to. So the only difference between these last two graphs and these two graphs is that it's less than or equal to, which means my line is going to be the only thing that changes. So instead of a dashed line, it's going to be a solid line. So I have a solid line here, solid line there, and I went below both of these lines. So I went below this line because it's less than or equal to, and I went below this line because it's less than or equal to. Okay, so these are the bare basics. These are just some nice diagrams to come back to if you're ever confused or ever unsure of what section to shade when you are graphing. Okay, so now let's walk through actual examples. So on page 2, let's go through an actual example together. Okay. In order to graph our inequalities, it's easiest when it's in slope-intercept form, okay? And we want to graph this basically the same way that we have graphed almost every equation in the past. We want to look for our slope and y-intercept, okay? And we're getting to the point where, guys, I might not be giving you your slope and y-intercept slots anymore. And if you're the type of person that needs to write them down just so it's easier for your graphing, please do that, okay? Otherwise, I think we're starting to get to the point where you can identify them. You can identify your slope and y-intercept without having to write it down and just transfer straight to the graph. But again, I'm going to show you writing it down just in case you need that as well. So slope and y-intercept. My slope is the number in front of x, so it's 2. If you want to make it a fraction, go ahead. So put it over 1. My y-intercept is going to be 3. Okay, so now before we actually go to graph, I want to put the points on my graph for graphing. So I want to put my y-intercept and then count out my slope and put my points, but I'm not going to draw my line yet. So I have a y-intercept of 3, so we want to go up 3. Let's go off of this dark line. Okay, so ignore this little line. We're going to go off of the dark line. So 1, 2, 3, put a point. Okay, I have a slope of rise 2, run 1, so up 2 over 1, up 2 over 1, up 2 over 1. And I go down 2 over 1. And I put as many points as I can fit on the graph. And guys, this becomes more critical now than ever. I've tried to get you into the habit already. And I know it kind of seems silly, but this is when it starts to come into play. Just like when we were graphing in 7.1, it's important that we have all of the points on the graph because we don't know where the intersection is going to be. And as always, guys, we're going to build off of this. So this is the bare minimum, and we're going to have to build off of this. So it's good if you get into the habit now of putting as many points as you can. So that way later on it's easier for you to see the bigger picture. All right, so we identified slope, y-intercept, and we put all our points on the graph. Now, we can't just go draw the line and be done because this is a different section, right? We have shading that's involved now. So we have to figure out what the symbol is. We have to figure out what type of line we have. So is it going to be a solid line or a dashed line? And then we have to figure out where on the graph we're going to shade. So this symbol, what does this symbol mean? Is it greater than, less than, greater than or equal to, or less than or equal to? And it's less than or equal to, it's just less than. So because it's less than, is that going to be a solid or a dashed line? It's going to be a dashed line. So I'm going to put an arrow here at the end. And to keep my dashed lines easy, what I like to do is actually play connect the dots with every other set of dots. So I skip this one, connect this one, skip that one, connect the next one, and follow the pattern all the way up. And then put an arrow at the end. Okay, so again, there's my dashed line. It's nice, obvious, and dark. Okay, but it's not super dark that if I make a mistake, I can erase it. All right, and now we need to shade, so it's less than. Our symbol is less than, okay? So am I going to shade above my line or below my line if it's less than? I'm going to shade below. And again, guys, be pretty quick and clean with your shadings. You don't have to get every box perfectly filled in, but it shouldn't look sloppy either. So do a quick. There we go. Okay, it's obvious as to what my line is, and it's obvious where I'm shading. So that's what your graph should look like. Okay, so now example number 2. This guy's a little bit different. Okay, how so? How is it different from the first inequality we just graphed? Look at your x's and y's. Are they in the same spot as up here? No. So it requires a bit of work before we just jump in right away and start graphing. We got to get this y by itself. Okay, so I'm going to go and circle it. draw my line. I need to solve for y. I need to get y by itself. So the first thing we're going to do is subtract 3x on both sides. Don't forget that this 5 is negative here. Okay, so we've got negative 5y less than or equal to, keep the sign the same, negative 3x plus 10. And if you reverse those and it said 10 minus 3x, that's fine. It's the same thing. Still need to get y by itself, so I'm going to go ahead and divide by negative 5. Divide this whole thing by negative 5, so I get y. Remember what happens when you divide by a negative. I said this in the beginning. What happens to my inequality symbol when I divide by a negative? It flips. Okay, so don't forget that when you divide or you multiply each side of the inequality by a negative number, you have to flip that inequality symbol. Okay, negative 3x divided by negative 5 gives us positive 3 over 5x. Positive 10 divided by negative 5 is negative 2. And now this is my new inequality that I'm going to work with. So now if you need to write out your slope and your y-intercept, do it. If not, start graphing right away. So we get a slope of 3 over 5, y-intercept of negative 2. So then come over to your graph. Y-intercept of negative 2, go down 2. A slope of 3 over 5, so rise 3, run 5, 1, 2, 3, 4. 5, 1, 2, 3, 1, 2, 3, 4, 5. Down the opposite direction. Okay. All I did was put my dots on the graph. Now I need to go back and determine what is my inequality symbol. So what kind of line am I supposed to have? It's greater than or equal to. So the or equal to tells me it's going to be a solid line. So I can draw a line through my points, arrows at the end. My symbol is greater than or equal to. So do I want above the line or below the line? I want above the line because I want the values that are greater than or equal to my line. So I'm going to go ahead and shade this entire section. So again, it's easy to see the type of line that I have for my inequality. It's also very easy to see what section I shaded. So take your time, be neat, and if you have questions, let me know.